And now let's go to what we were talking about, which was the pruning curve. So this is the pruning, and we are back to the generator settings. So let's go for pruning. And as you know, this pruning is maxed out. And this is the amount of maximum of what we have created. So let's say that in the center, we want to prune a lot of the branches and break them and lose them. And you should remember that this prune curve is also a parent curve. And it's going to be based on the parent that you assign to it. So the parent is now the trunk. This trunk, we want to cut off all of the branches into here. So let's choose a couple of points for the center and do some checkpoints in here so that these do not change, and bring this down and bring this down also. And you see all of these center ones have been pruned. But if you want to do anything else, for example, you can use these presets, for example, linear decay, make them appear in the end. Or linear growth is the reverse. Or there's the S curve, which you have a lot of flexibility to make your changes. And of course, there are some other curves which we will discover later on if we had a chance, because they really do not have basic uses and are for advanced users. And I feel like this is enough for introduction course. So after covering the shared properties and of course these curved ones, we are ready to move on to the modes themselves, which are these ones that you're seeing here. And these are the most important factors when it comes to tree creation inside a speed tree, because each of them has certain algorithms to help you out creation of the trees easier. So let's, as always, create a branch in here and go for the modes. The first one is classic, and it's recommended that you do not use this mode ever, because this mode has been replaced with other modes, and it's only there to support the old works that you might want to import from older versions of a speed tree into the current version, which is 9. And I recommend that you never use this one. But it has some amazing concepts that can help us understand these modes better. And the first one is the style. The style is either going to be absolute or relative. If the style is set to absolute, the number that you enter here are going to be the number of the nodes that this generator is going to be creating. For example, the node is now on 1, and we are getting only 1 node. And if I set it to 2, we are getting 2 nodes. And if I set it to 3, we are getting 3 nodes, and 4 nodes. This is called absolute. And the absolute number that you enter here, you are getting that in the nodes. But if you set the style to be relative, this relative is looking at the height of the parent, in this case this trunk, and generating the number of nodes based on the height of this parent. And now this frequency number isn't so true, and it's like a slider. The more you put it up, the more you are going to get the nodes. And if I set it to absolute, you see that now we have 21 nodes. But if I set it to relative, it's going to be a floating value that is generating nodes based on the height of the parent. And if I take this one, which is the parent, and go to the length and increase the length, you see that although the number is the same, but we are getting more and more nodes generated in the children. But if I set the mode of this one to be absolute, we are getting the same number no matter how long or how small or how big or anything the parent be. It's going to be always staying the same. So this is a great concept to understand. And the next concept to look at are the steps. And if you enable this step, it's going to make them clustered into steps that are similar into the length. And now you see we have individual steps in here, 1, 2, 3, 4, and 5, depending on this number that we put in here. So let's go in here and set the numbers to be 5. And now you see we get 5 individual steps. And if I disable the steps, they're going to be randomly placed. But if I enable the steps, they are going to be placed in the order. And the amount of the nodes that you get per step is the frequency, if it's absolute, the absolute frequency divided by the steps number. And now you see the frequency is 5 divided by 5 in here is 1. And we are getting 1 node in each step. And if I make it 10 divided by 5 equals 2. And now we get 2 nodes per step. And if I make it, for example, 15, we are getting 3 nodes for 1 step. And if I go for 20, for example, we are getting 4 nodes per step. And then we have the spread, and this spread allows us to randomize the placement of them. You see, every step in here has a certain center point, and each of them have been placed. For example, there's a center point in here, and they have been placed around this center point. And if I manipulate this spread, they're going to be offsetted from the center point and make it more natural. And the next one is roll, and the roll is something like the rotation. If I look at it from the above and try to increase the roll value, it tries to place them and rotate them a bit more natural, so that we do not have something that is so procedurally created. And then we have this check number, which is per step frequency. And let me make this one a smaller, for example, 5. Okay, now we have 5 nodes being generated in here, and we have the spread and roll also manipulated for us. And let me make this one 0 also, so that we get this. Okay, if we enable the per step frequency, the number that we put in here is going to be created for us in here per step. For example, if I make it 2, we are getting 2 nodes in each step. And if I make it 3, we are getting 3 nodes in each step. And then if you look at it here, we have a curve that is in orange, and that is the distribution curve. And I would rather explain this into next mode, which is proportional. So this was the classic mode, and I really recommend you not to use this, because other algorithms in here are a lot more naturalistic and realistic as well. And this is only to support the older speed tree works if you have created in previous iterations of a speed tree. So let's go for the next one, which is the proportional. This mode generates the number of nodes based on the length of the parent. And it's awesome for creating randomized things. For example, if we decided to create multiple trees in here, let me select the main trunk, and in the numbers, let's make them 5, for example, and go to position and make them randomized a bit. Okay, now I want to go to the spine section so that I can manipulate the length. I'm going to put 5 for each of them, and for the variance, I'm going to increase the variance to 20 so that we have a lot of randomization there. So you see, although we have the generation set to 2, we are getting lesser numbers in smaller trunks and bigger numbers in bigger trunks. And it creates a good randomization, and the bigger trees get more trunks and branches. And it's all dependent on the length and the size of the parent. And the number that we have here is relative, just like what we had in classic, which was having absolute and relative. The number in here is relative, and it means that the more number I try to add, it's going to be multiplied by the length of the parent. And then there's the jumbo, which adds a bit of randomization into them so that they are not so procedurally looking created. And this adds a bit of randomness into there. And this sweep, let me look from above. this sweep tries to rotate them so that we have more randomization in the nodes, so that when we look at them from the above, they are not so looking procedurally. And the roll is also, as the name suggests, rolling them all in the same direction that you are rolling. And then we have favor split, and if you increase the number, it's going to spawn the nodes based on the geometry of the parent, and it's going to spawn them on the areas where the most conflict is going to be, and it's going to make them spawn on major bends. And if your tree has a broken part or anything, it's going to spawn the branches there so that it makes it a bit more natural to look at. And when the aligner style is set to group, it's going to create a procedural algorithm for all of them to have the same increment between the degrees. But if you make it individual, let me select the branches and let me make it individual, it's going to alter some of them so that when we roll them, it has more randomness in the areas and not all of them appear on the same increments. And it creates more randomness in there as well. And then we have this orange, which is the distribution curve that we were supposed to talk about. And this distribution curve manipulates all of the nodes at the same time, just like the parent node or profile node or any curve editor that we have. But the difference factor is that whenever we select a parent curve, for example, and we bring this down, we are actually removing from the numbers of the nodes that have been generated. But the distribution curve differs in the fact that it only distributes the number of nodes based on this curve that we create here. And it's not going to remove or do anything. It's only going to distribute the nodes based on the curve that we apply here. And you see, when we do something like an S-curve, or even better, min, you see now all of them have been gathered in the bottom. And if I select both of these and bring them to top, you see the distribution factor gets affected and it's going to distribute them a lot better. And for example, if I create a point here, let me bring this to min so that all of them gather in here. And if I create a point in here and bring this up and create a couple of checkpoints, and let me bring this down and create one in here and bring this one also. It's going to center them and spawn in the center unless they're in the base or the tip of the trunk. So it's not about adding or removing anything, it's only about distributing them based on this curve that you assign here. And the next one is the proportional steps. Let me add some branches and set the mode to proportional steps. And this mode is just like the previous one, the proportional, which is adding the nodes based on the size and the length of the parent. And the value that we add is going to be relative. And you see that in the larger trunks, we're getting more branches, and in the smaller trunks, we're getting smaller branches, a smaller number of branches. But there are some couple of settings that makes it different from that. The first one is being steps. So you're familiar with the concept of the steps that we covered in the classic mode. So if I increase the steps, it's going to increase the step for us. And we're getting the same intervals between the steps. And then we have this per step setting. And this setting is going to be applied to every step individually. For example, if I increase the number, it's going to increase the number per step. For example, you see in here we have a lot of steps, and per step we have a couple of nodes. And if I increase this, we are getting 3 nodes based on every step. And I'm looking at this smaller ones because it's easier to explain. So if I increase this, make it 4, we are getting 4 steps, 4 nodes in each step. And this offset is going to offset them up and down so that we have a little bit more naturalistic result, so that they're not all aligned in the same step. It's going to offset them in up and down direction to make the procedurality a bit more naturalistic. And this roll value, as we have covered before, is going to roll them and make the rotation a bit more random. And after that, we have the sweep, which is going to alter the rotation, and of course the general roll, which is rolling all of the nodes at the same time. And this align we have covered in the previous one. So you see that after covering some of them, all of the settings and a lot of the settings are similar to each other, and we really do not want to cover them every time because they share a lot of the properties. And the next one is absolute and absolute steps. So I changed the branches generation mode to absolute. And unlike the proportional editing, which was relative, this absolute mode, as the name suggests, is absolute. And no matter how tall or small or big or tiny the trunk is, always it's going to spawn a fixed number of nodes on the parent. So on here we have the number 1, and if I decrease it, now we are getting 5 nodes on each parent, no matter how big or small the trunk is. And then also we have these familiar settings. Jumbo makes it a bit more randomized, and then sweep is going to rotate, and roll also rotate all of them at the same time. And these settings also we have covered previously. So let's go for absolute steps. And it's like the absolute, which it doesn't really care how big or small the parent is. It's going to always spawn a fixed number of steps on the trunk or on the parent. So now I decide to add 3 steps, and you see, regardless of the size of the parents, all of them are spawning the same number of steps. And then also we have these familiar settings. For a step we want to increase, and we are always getting the exact number that we add here. It's exactly opposite to the proportional steps. And in proportional steps, we had the numbers to be relative, and the size of the parents really mattered there. But in absolute steps, the size of the parents doesn't really matter, and we add any number, we get it perfectly. And the next mode is called the phyllotaxy. And this phyllotaxy is great for creating leaves. And of course, the meaning of the phyllotaxy itself is arrangement of the leaves around the stem. And we are going to do a lot of things with this phyllotaxy. And this is a perfect example of phyllotaxy in nature. You see, it creates this nice spiral. Of course, this spiral is only one of the usages of phyllotaxy, and there are multiple uses which we cover later on. So you see, all of them have been rotated around this single stem here. And this is the basic idea behind the phyllotaxy. So let's see what phyllotaxy has to offer. The first mode in here is the arrangement. And the arrangement, let's set it to opposite. And it's the opposite distichus. And it's good to know that the phyllotaxy mode creates these nodes in the groups based on these two values that we put here in the boundaries, the first and the last. And these are two clamp values so that we do not see anything after or under these values. And all of these styles that phyllotaxy has to offer have a property called the nodes. And this node is going to be responsible for moving the nodes out based on the length of the parent. So the internode length, self-explanatory, is going to be the length between the nodes. You see this distance here, and if I increase it, you see the distance is going to be much higher, and the nodes that go under this 0.20 value are get clamped and removed. And if I make this one less, you see those clamped ones in here. So this first and last are very important. And the more you increase the internode length, the lesser nodes you are getting. and the lesser you make it, the more nodes you're getting. And the next one is a spread, which is good for randomizing these groups. For example, they have been placed in here in groups. If I increase the spread, it's going to offset them a little bit on the up vector and up and down to make it a bit more realistic. You see now the spread is 0. All of them have been placed regularly on intervals. And if I make the spread a lot higher, you see more randomization happening in here. And then we have this spiral, and that spiral creates that image that we saw there. Let me go to the top view and manipulate the spiral. And this spiral, you see, creates that spiral shapes that goes something like this onto the sky. And it's good for creating flowers or trees that have a spiral into them. And let me disable this spiral to explain the next one. And the next one is the limit. And it's going to limit how many groups that we can create using this method. And by group, I mean nodes that are grouped together. And if I make the limit higher or make the limit lower to see that, you see now it only limits that to 8 groups. So let's count them. And of course, let's make the spread 0 so that they are not offsetted. So let's count the groups. 1, 2, 3, 4, 5, 6, 7, 8. You see, each of them are groups. And this value limits how much groups we can have. So now we have 11 groups based on the spread, based on the internode length, and based on the first and last value that we give it here. So let's go for arrangement nodes. The first one is the opposite disticus, and it's going to make nodes parallel to each other based on this first and last value that you give it here. And they're all going to face to the same direction if you do not do anything, change the spiral or rotation or anything. And the next one is going to be opposite dicassette, and it's going to do the same thing, but it's going to rotate each group 90 degrees from the previous group. So let's activate it, and now you see we have a group here, and then the next group has been rotated 90 degrees. And as you know, all of the settings are here and they are the same. And we have pretty much covered them all. And the next one is opposite, and it's going to do something like this, but instead of rotating them in a 90-degree fashion, it's going to rotate them a bit more randomly and giving it a much more realistic result. And of course, using this spread, a spiral, and these settings, you can make it pretty much so natural. So let's go for the next one, and it's the alternating disticus. And in nature, it's something just like the opposite disticus, but instead of having multiple nodes in the same group, it has only one node per group, and they appear in a zigzaggy fashion on the parent. So let's activate the alternating disticus. You see, from each group, a node has been removed, and the remaining node is in the opposite direction of the previous node, a little bit higher or a little bit lower, depending on the left side or right side. And then we have the alternating itself, and it's just something like this, but the orientation of them is random instead of being so mechanical. You see, now every group has only a single node, and the rotation is random instead of being so mechanical. And the next mode is, the next style is the world. And if you activate it, you're going to get this property children per node, and it's going to assign how many children we are going to have in a group. And if you disable it, you're getting less in each group and each step, if you remember. And if you increase it, you're getting more in each step. And of course, if you want to make it more natural, just go for spiral, a spread, rotation, and a bit of position to make it more natural. Okay, see you in the next lesson.